In part 3 of our lesson on polar equations and graphs, you will learn how to sketch the polar equation graph of a Limacon. In this example, we are being asked to sketch a graph of r equals 2 plus 3 sine of theta. Now remember, in the previous lesson, we just worked out all the symmetries of this graph, and we discovered that of the three symmetries, it had one type, and that was it is symmetric to the theta equals pi over 2 axis. So we will use its symmetries to simplify the graphing process. There are a couple of useful approximations we will want to use because of the trig function values. And anytime we have a function value of radical 2 over 2, we will use 0.7 in our graphing. And for radical 3 over 2, we will use 0.9. Now, one comment I will make is that graphing in the polar coordinate plane can be a long, kind of tedious process. So I have empathy for you on this, but you just got to hang in there. So let's get started here and see how it goes. We will start with theta equals 0. We know that the sine of 0 is equal to 0. So to find r, we will be doing 2 plus 3 times 0, which is equal to 2. So that means in polar coordinates, we will be plotting the point 2, 0, because remember the value of r comes first and the value of theta comes second. Now over here on the graph, what this tells us to do is point towards an angle of 0 and walk out a distance of 2. So we start here at the pole. Remember, that's like the origin. We start here, we're pointing towards 0, and we walk out a distance of 2. So that would be 1, 2, and we put a point there. Next up, let's plug in pi over 6. We know that the sine of pi over 6 is 1/2. So to find r, we are going to take 2 plus 3 times, I would suggest you use 0.5 and think in decimals instead of using a half. We know that 3 times 0.5 is 1.5, so 2 plus 1.5 is 3.5. So we will be plotting the point 3.5, comma, pi over 6. So that tells us to look at pi over 6 and walk out a distance of 3.5. So we start here at the pole and we go 1, 2, 3, 0.5, and we put a point there. The next angle is pi over 4. We know that the sine of pi over 4 is radical 2 over 2. And we know for radical 2 over 2, we are going to use 0.7. So to find r, we will do 2 plus 3 times 0.7. 3 times 0.7 is 2.1. Add 2, and we get 4.1. make sure that you're able to multiply these kinds of decimals without a calculator. Don't use your calculator on any of your homework because you won't be allowed to use it on your exam. So make sure that you are practicing multiplying the decimals in your head without a calculator. Okay, so we found r is 4.1. So the point we're going to plot is 4.1 comma pi over 4. So we come over to our coordinate plane here, and we go out a distance of 1, 2, 3, 4.1 towards pi over 4. And we have to estimate, just like you would in the rectangular coordinate system. Next up is pi over 3. We know that the sine of pi over 3 is radical 3 over 2. So this becomes 2 plus 3 times its decimal equivalent, which is 0.9. 3 times 0.9 is 2.7 plus 2, 4.7. So we will plot the point 4.7 comma pi over 3. So we come over to our coordinate plane, start at the pole, look towards pi over 3, and walk out a distance of 1, 2, 3, 4.7. Next up is pi over 2. The sine of pi over 2 is equal to 1. So we will do 2 plus 3 times 1, which is 5, and plot the point 5 comma pi over 2. We start at the pole, we look towards pi over 2, and we walk out a distance of 1, 2, 3, 4, 5. So here we did the quadrant 1 angles. And let's go ahead and connect those. We get a smooth curve. Now, before we plug in the quadrant 2 angles, we want to remember that this graph has symmetry with respect to the theta equals pi over 2 axis. So we are going to actually get a whole bunch of points for free that we don't have to go through the tedious process of plugging them in. So let's take a look at that now. One thing that you have to be careful about with a polar graph is that the points have to be connected in ascending order of the angles. So at pi over 2, we know the next angle we would connect to would be whatever point is at an angle of 2 pi over 3. Now, using this symmetry here, remember this is going to fold over the vertical axis here, the theta equals pi over 2 axis. So we know that the point 4.7 pi over 3, this one, is going to fold over and become the point 4.7 comma 2 pi over 3. So we get that point for free. And the point 4.1 pi over 4 right here is going to fold over and become 4.13 pi over 4. So that will be right here. The point 3.5 pi over 6, which is right here, will fold over and become 3.5 5 pi over 6. So it's really nice that we don't have to plug these in. And finally, 2, 0, which is right here, is going to fold over and become 2, comma, pi. So to find the angle for each of these, all we had to do was take pi and subtract the original angle. So pi minus pi over 3 is 2 pi over 3. Pi minus pi over 4 is 3 pi over 4. Pi minus pi over 6 is 5 pi over 6. Pi minus 0 is pi. Because remember that the symmetry test for theta equals pi over 2 is that we plug in pi minus theta. That's the test. And so that's how the angles will be related to each other. Every angle here will just be pi minus this angle. We need to plot 2 comma pi, which would be here. And now we can connect those points in order. Again, a smooth curve. There are no jagged edges here. So from our quadrant 1 angles, we got our quadrant 2 angles for free. We will need to plug in the quadrant 3 angles. So remember, in our graphing, we got as far as theta equals pi here. So we got to pi. The next angle is going to be 7 pi over 6. The sine of 7 pi over 6 is negative 1/2. So when we figure out r, we will do 2 plus 3 times negative 0.5. So this becomes 2 minus 1.5, which is 0.5. So we will be plotting the point 0.5, comma, 7 pi over 6. So let's go ahead and do that. We've got to start at the pole. We walk out towards 7 pi over 6, a distance of 0.5, and put our point there. We can connect, again, smooth curve. Next up is 5 pi over 4. We know that the sine of 5 pi over 4 is negative radical 2 over 2. So to find r, we do 2 plus 3 times negative 0.7. So this becomes 2 minus 2.1. So this is negative 0.1. It's our first negative radius of graphing here. So we will plot the point negative 0.1, 5 pi over 4. So that means we start at the pole. We are looking towards 5 pi over 4, but instead of walking towards 5 pi over 4, we have to back up away from 5 pi over 4. So that would be here. It's such a tiny number, it's hard to see. Connect that in the curve. After 5 pi over 4, we have 4 pi over 3. The sine of 4 pi over 3 is negative radical 3 over 2. So to figure out r, we will do 2 plus 3 times negative 0.9. We know this is negative 2.7, So we're doing 2 minus 2.7, negative 0.7. So our point is negative 0.7, comma, 4 pi over 3. So you start at the pole and you look at 4 pi over 3, but you are not going to walk towards 4 pi over 3. You are going to back up away from 4 pi over 3. So you see this line here, and you have to back up by 0.7. Let this curve there. After 4 pi over 3, we will do 3 pi over 2. We know that the sine of 3 pi over 2 is negative 1. So we are doing 2 plus 3 times negative 1. 2 minus 3 is negative 1. So we will plot the point negative 1, comma, 3 pi over 2. So that means we start at the pole. We look towards 3 pi over 2, but we aren't going to walk that direction. We have to back up away from 3 pi over 2 to negative 1. Continue the curve here. Now let's use our symmetries. After 3 pi over 2, we are going to need 5 pi over 3. So if you imagine folding 4 pi over 3 over the vertical axis, 4 pi over 3 is going to land at 5 pi over 3. Now, if you did the calculation like we did earlier, where you did pi minus 4 pi over 3, you see that you would get negative pi over 3. And negative pi over 3 is coterminal with 5 pi over 3. So it still works to do that method where you take this angle and subtract it from pi, or you can just visualize that 4 pi over 3 folded over becomes 5 pi over 3. So this becomes negative 0.7, 5 pi over 3. So that means we start at the pole. We are looking towards 5 pi over 3, but we don't walk that direction. We have to back up away from 5 pi over 3, a distance of 0.7. So it's going to curve around here. 5 pi over 4, this angle, if we fold it over the vertical axis, will land on 7 pi over 4. Or, remember, you can do the subtraction. Pi minus 5 pi over 4 is negative pi over 4, which is coterminal with 7 pi over 4. So this becomes negative 0.1, 7 pi over 4. So starting from the pole, we look at 7 pi over 4, but we don't walk towards it. We back up by negative 0.1 here. Again, so close it's hard to see that one. Here, 7 pi over 6, if we do the subtraction, pi minus 7 pi over 6 is negative pi over 6, which is coterminal with 11 pi over 6. Or you can visualize the symmetry. 7 pi over 6, if we fold it over this vertical axis, will land on 11 pi over 6. So this becomes the point 0.5, 11 pi over 6. So this is a positive radius. So we start at the pole and we will walk towards 11 pi over 6, a distance of 0.5. We continue our curve. And lastly, we just have to plug in 2 pi. It's the only one left. We know that the sine of 2 pi is equal to 0. So this becomes 2 plus 3 times 0, which is equal to 2. So we will plot the point 2, comma, 2 pi, which we know that 2 pi is coterminal with 0, so we've come all the way around, and we connect that last curve. And now you can really see the symmetry to the theta equals pi over 2 axis. This entire kind of curlicue here folded over the axis and landed on itself. So we plugged in the quadrant 1 angles, and we got the quadrant 2 angles for free because of that symmetry. So we plugged in quadrant 1, and we got quadrant 2 for free. So after quadrant 2, we plugged in the quadrant 3 angles right here. And from the quadrant 3 angles, we actually got this purple section here, purplish gray section. And from the quadrant 3 angles, then we got the quadrant 4 angles for free. We plotted those. We plugged in 2 pi to finish one full cycle, starting at 0 and finishing at 2 pi. And this is the graph of a Limacon.